Welcome to PNW Weather 101, Episode 5. This is going to be a sample on what the National Weather Service does. I'm changing the schedule of PNW Weather 101 because of the news that's happened the last couple of weeks with the layoffs that have occurred in the National Weather Service. I'm meteorologist Hans Leach going over this topic, and I do want to note as a disclaimer, this is not going to go over everything that the National Weather Service does. This will have a focus on what you as a consumer and myself as a meteorologist use for the National Weather Service. Their mission statement says that they provide weather, water, and climate data, forecasts, warnings, and impact based decision support services for the protection of life and property and enhancement of the national economy. The history of the National Weather Service, it originally started out more militaristic than it is today. It was first created on February 9th, 1870, before it was changed to more of a all-encompassing weather bureau in 1890, and instead of being a military operation, it was put under the Department of Agriculture. It was later changed to the Department of Commerce in 1940, and then when the National Oceanic and Atmospheric Administration was created, the National Weather Service was put under that. NOAA is still under the Department of Commerce, however. So, watches and warnings. I go over the National Weather Service watches and warnings on the first slide of every forecast that I make because they are the only weather agency allowed to produce official watches and warnings. These watches and warnings are based off of the National Weather Service's forecast, not anyone else's. And also, if you need a description of what the thresholds are for each watch and warning, I do have a video of that on a earlier PNW Weather 101 episode, so I will link that in the end cards and in the description. They are also the only weather agency with EAS clearance, which stands for the Emergency Alert System. This only triggers during severe weather warnings, specifically a severe thunderstorm, tornado, or snow squall warnings. Those are the ones that are least possible in our area. It can override any activity being done on a TV or phone to deliver said warnings, even overriding silent mode if deemed necessary. Watches and warnings can be based off of their forecast for an area or current observations via radar. The current observations via radar is required for a severe thunderstorm warning or tornado warning if there is no storm spotters in the area. Now, for the local forecast offices, there's 122 nationwide, and there are six that are located in Oregon or Washington, plus the Boise office, which, while centered in Idaho, does cover southeastern Oregon. Each local office is responsible for the production of their own weather forecasts and are the ones that issue most of the watches and warnings, with the exception of the severe thunderstorm and tornado watches, which are from the Storm Prediction Center, and the river flood watches and warnings, which are from the river forecast centers. They also do aviation and marine forecasts, which is especially useful for operations out of PDX because it determines which direction planes will take off, and that can also affect how many flights can take off for per hour. It also helps PDX just run a lot more smoothly when they know what to expect in the air. They also issue area forecast discussions on current conditions that goes more into depth than what a traditional 7-day forecast shows. The river forecast centers, there's 13 nationwide, which also includes the Northwest River Forecast Center. That office is in Portland, and that covers the entire Columbia River Basin, plus most of the coastal waters from the Oregon California border on up into the Washington British Columbia border. They are responsible for river flow, flooding, runoff, and soil water content. And that combined with the local forecast offices, precipitation, and forecasts, outlooks, and snowtel monitoring, that all combines into the drought monitor. They also maintain all of the weather facilities that we as meteorologists use. And at least when it comes to radar, I know a lot of you look at radar as well. There's at least one radar for each local weather office. So for Oregon and Washington, there's a net total of seven. So there's one for each office, and there's one off of Langley Hill. So the Langley Hill radar in Southwest Washington was the last of the current models of radars. It was actually built using spare parts. And this model of radar, I believe, is called the NexRad radar, and a suitable replacement has not been developed publicly or privately. And radar is important because it can detect severe storms without the need for storm spotters, or more often, the more common use for in the Pacific Northwest is just seeing where and how heavy rain or snow is falling. One thing I do want to note about radar is that there's two considerable radar gaps right here in Oregon. The first is in the southern Willamette Valley and the central Oregon coast, which includes Eugene, and the second is in central Oregon. These two radar gaps provide radar coverage to 10,000 feet or so if you're lucky. The Central Oregon Gap, there's many areas that are completely blind. And as a result, these two areas have the highest population in centers that are in this blue area. Every major metro area that is bigger than Eugene or Bend is in either this orange color, which signifies radar coverage about 6,000 feet above ground level, or in this lighter yellow color, which is 3,000 feet above ground level. Pretty much every major metro area is in this lighter yellow color, with the exception of Charlotte, where though the city proper is in the lighter yellow color. Some of the northern suburbs are in this darker yellow color. So that's another radar gap that should be addressed in the future. A future PNW Weather 101 episode will go over these radar gaps and if there is anything being done about them. They also keep all climate records for official stations across the US. And if you want to access any of these climate records for yourself, they are found using the Applied Climate Information Systems database. And the National Weather Service also maintains the ASOS stations, which are the automated stations that record all the conditions, temperatures, and precipitation amounts, though only a select few measure snow just because human intervention is normally required for that. For here in Oregon, the only ones that I know for sure officially register snow that is National Weather Service maintained is Portland, Eugene, Medford, and Pendleton. There are some public-private partnerships that are considered official stations, like the downtown Portland station, which is maintained at the KGW studios in the Goose Hollow neighborhood. And they also measure the snow totals for downtown there as well. So, for example, when you see the high on February 27th is 70 degrees, that means the high at PDX was 70 degrees because that's the official site used for Portland. That also means when you see that temperature on your phone app or on TV, that's the temperature at that specific site. And generally, these official stations are at airports. They also release weather balloons at sites nationwide to provide data on upper level conditions, including but are not limited to temperature profiles, upper level winds, and pressure thickness. The local launch site is in Salem. Normally, these are not at major airports due to the air traffic. So, because Salem doesn't have a lot of commercial flights, that's why it is launched in Salem rather than Portland, which logically would seem more useful just because of the higher population in the Portland metro area. This data is fed directly into weather models, both US based ones, like the GFS model, and non US based ones, like the Euro model. I will also mention with weather models that some of the higher resolution model, like the HRRR model, also takes into account radar data as well, making that radar gap even more of a problem. With the exception of the graph model, all the US based models that are not limited to private company use only are provided from the National Weather Service. Some companies create their own in-house model for their own forecasting needs, and it's generally niche in terms of the areas they forecast and the parameters they forecast for. These weather balloon launches are commonly seen as the most useful data that is collected for forecasting just because of all the ripple effects throughout the not just us seeing that okay conditions are looking this way or the other way, but because they're fed directly into the weather models and provides a ton of useful data for them to create the most accurate model that can possibly be created. Then, lastly, I will go over the public private partnership with the National Weather Service. So, private citizens can help the National Weather Service report conditions via the Skywarn program. Skywarn is how you could get officially trained to be a storm spotter. And once you're trained, you can report conditions to the National Weather Service. And normally, for my snow totals, I utilize the public information statements, which are taken at the official observing sites, and also include reports from Skywarn spotters. Private companies also utilize the National Weather Service and its products for both using them for weather forecasting and using their tools to develop their own forecast. And in terms of how much value they provide economically, and I'll link the citations in the description below. A American Meteorological Society estimate shows that for every $1 used on the National Weather Service, $10 is returned to the US economy. For the internal estimates ordered in 2018 from NOAA show that the National Weather Service earns the US economy about $11.60 for every $1 invested in the National Weather Service. It's also backed up by a third party study, which I'm linking that specific third party study rather than the actual NOAA internal estimates because it took math calculations to calculate that $11.60 versus this is just a graphic in that study, making it a little bit easier on the eyes. PBS has also estimated can be as much as a $50 or, or return to every $1 invested. Now, I will note that the estimates above do not include supporting the private meteorological industry, like, for example, this YouTube channel, and then also all the TV forecasts that you see locally and nationwide, for example, the Weather Channel. And then also, one thing I'm not mentioning here because you can't really put an economic value on it is the lives they save through the watches and warnings as well. So that is going to be it for this video. The next video will be the winter weather recap video that I do in early April now compared to the previous dates before last year of mid-March. And I will also be doing my way too early forecast again for next winter. I also do apologize that this video is late. Um, in this case, I do have a broken elbow right now. Let's just say typing this was a little bit difficult considering it is my dominant in hand, though it is well enough that I was able to type all this up finally. So hopefully that heals up entirely by next video. Knock on wood right now. So until then, stay safe out there. Please do not break your elbow or go on any muddy dirt trails running, especially without trail runners, and take care.